I want to point out that there are like some issues. Maybe they can be overcome in the future. So one is that in Lambda function, you can't really freely choose the language you want to use or the version you want to use. So I still use AWS as an example. So if you want to write some Lambda code, you can choose between Java, Python, and JavaScript, or Node.js. Yeah, Python, Java, Node.js. So and also they give you the version that you can choose. Like for example, Node.js, you can choose only version 4 or version 6. Because they are the service that runs this code, so your code has to be aligned with the set of environment they provide to you. Okay, so the other thing is that if I have a local service, like a local, let's say Node.js server, I make some change, I can run it locally, and I'll be able to save the changes right away, and I'll be able to test it manually. But in the Lambda, because the code no longer runs on your server, it has to run in this Lambda container. So you have to deploy it somehow, and then you'll be able to you'll be able to see your change. Yeah, but I think those are not very big issue, and there should be solutions. Okay. So those are the so we went through the some techniques that we can use to build our tech stack. But there's some tips I want to share with you how to like implications if you go this route. So we say this like this stack before. Right? We have a load balancer and we have some server behind the load balancer. So it looks simple, but it looks simple only because I hide a lot of details. So the actual architecture is. It looks like this. So we have VPC, we have subnets, we have to define routing tables, we have internet gateways, we have permission control. We need to have monitors, we need to have auto-scaling mechanism. So it's complicated. And it's even getting more complicated when we add those Lambda function storage service. You have to connect them in the right way. And also, we need to have two stacks. We need to have a broad stack, and we need to have a depth stack. So you can imagine that if you really want to manage this by hand manually, it will become messy very quickly. So what should we do then? Actually, there are some tools that you can use to generate those infrastructure by writing some configuration. So you can define all those infrastructure, you can define the configuration, you can define how they should be connected to each other using file, like using configuration file. And then you can run the tool, so you will build all those infrastructure for you. And then, if you want to make some change, instead of go change them directly, you change the file first. You change the file, you run the tool again, so it will update your stack with this new changes. You test it in your dev stack. Make sure everything is fine. You run the tool again to replay those changes on your prod stack, and you made sure that you made exactly the same change you made to the dev stack, and they are exactly they kept sync. They always kept sync. Okay, so the reason is that now infrastructure, we can say that in a modern distribution system, the infrastructure is getting complicated, and it's playing a very vital role for your application to fulfill its function, fulfill its functionalities. Before, only the code is the complicated and most important part. Now infrastructure as well. So doing this way, you are putting all those infrastructure in as part of your code base. You'll be able to use version control to manage the infrastructure changes. Right? So you're able to keep track of every change you apply to your infrastructure. You can even roll back if you want. Okay. Okay, the next thing is test and monitoring. As you said, infrastructure plays a very okay. Let's talk about tests first. So we all know that tests are very important, and I don't think anyone is denying this. There's an old saying: I don't do tests. When I do, I test in prod. So this is to make fun of people, to those people who don't do proper tests before they roll out their change to prod. Okay? But tests are also hard. There are so many different kinds of tests. You have unit tests, you have integration tests, small tests. If you want to have a good coverage, you really need to put some effort to build all those tests. And the worst thing is that tests don't catch everything. So tests test your code, right? But it doesn't really test your infrastructure. Well, yeah, even though you can use some integration tests to test your infrastructure, but it's still hard. And also there are runtime issues. Say if your database is disconnected, if your DNS is misconfigured, so your client will no longer be able to reach your website. Tests don't catch this. And also cache failures. So if you cache some data and the call pattern changes, and all of a sudden your miss rates of this cache just go up very high, and then the service can crash. Okay. So then what should we do? We should have monitorings. So monitorings, we need to monitor the errors. It can be lambda invocation error. It can be like errors from your server. And also you can monitor the latency. If the latency was low and it goes up high, there can be some issue. And the call volumes. Not only when call volume goes up high, but also when if it goes up, it goes down to extremely low. There can be also some issues there, right? And you need to set alarms. So when there's some abnormality, you should receive, say, emails, or you should be receive messages on your cell phone to let you know that there can be something wrong in time. But and also I would argue that if you are a startup, it's just my opinion. If you are running a startup, you have limited resource, and you really can only pick one thing: tests from test and monitoring. Which one should you choose? I would argue that public monitoring is even more important because it really tells you how the system is running. Yeah, but don't put this online, otherwise you'll start a fight. So yeah.
Well, it seems to be a big challenge because the amount of time you spend testing and monitoring. Maybe some new things have come up. So standardization is not a reality in the sense. Every couple of years you're going to see something totally different. So it seems to be like a big trade-off between maintaining the status quo and exploring something new.
Yes, right. So yeah. Okay, but monitoring also has its problem, and the biggest one is this. So when you say something wrong in your metrics, when your monitor detects something wrong, your customers are already impacted. So you are actually letting your customer find bugs for you, right? Okay, but there is something I'm going to talk about how can we can fix this issue, and we will get benefit from test and monitoring at the same time. So there's something called canary test. So the name actually comes from some history anecdote. So mining, we all know that mining is a very dangerous job. So when the miner go into the tunnel working, there can be some dangerous gas leaking from underground, and and they can accumulate in the tunnel. So when you are aware of this dangerous gas, this toxic gas, usually it's already too late. So 100 years ago, there was no really good way to detect those toxic gas. What the English miners do was that they took a canary, a bird, in a cage. They bring them when they go down to the mine, and when they walk, they put the canary near them. The canary likes to chirp, so they keep chirping, but they're also more sensitive to the toxic gas. So when the gas starts to leak, it overcomes the canary first. So if you walk, and if you hear that the chirping stopped, you know something bad is happening. You should run. Right? So here we can do something similar in our test and monitoring. So we can set up canaries. So the canaries here are servers. So or they can actually, you don't need to on this server, you can use some external service to do this. So the canary basically is a server that keep calling your service, and you can let it to mimic the behavior of your customer. So you let the server keep calling. So it's not like test, you do it once. You let it keep calling, and then if everything's fine, then the canary will be just will be happily chirping. So now let's say if you have a change, you want to deploy a change. It can be infrastructure change, it can be code change. You deploy into your dev stack, and also you need to have monitoring them. So you deploy it to your dev stack. You stop. You stop and wait for a certain amount of time, like half an hour. So the canary will keep calling our server, and if something is wrong, if we say the canary stop the chirping, or if we say that we say that our alarms goes off, then we should go back. There's something wrong. Otherwise, when it's running fine, then we can push it into prod, but only one host only. And this host is the host that is connected to the external canary. So still, we do the same thing. We let it run for half an hour. If everything is fine, we roll it out to the other servers. So here, the good thing is that we are actually, so we know that test sometimes it cannot, actually it's now uncommon. Many of the times they fail to catch some issues because our test environments are actually different from our prod environment. If you are using setting up canaries in this way, we're actually really doing, we are checking if it's working fine in the real prod environment. Okay, any questions?
Is your customer the best canary?
But you want your canary to catch the failures before your customers do.
Probably the best, but not the cheapest.
Yes. Yes.
So technically, how do we mimic the behavior from customer?
How we do this, right? So I can actually.
Who or what is this canary?
The canary is owned by your
technical terms.
Technical teams.
Yeah.
Yes. So one way is that, so let's say if you have a web server, you have a website. How do you want to set the canary? So there are some tools. For example, the Ghost Inspector. So they can actually replay. You can do something like you can open your website. You can do whatever operation you want. You will record this operation and you will replay it. And you can schedule it to replay every minute. You can do complicated operation there. You can say, I want to do some transaction even there. So they can replay. So yeah, the more the better it mimics the actual customer behavior, the better you'll be able to find actual issues.
What would be the difference with the continuous integration?
Continuous integration, actually, okay, so the difference is that canary will keep calling your service, even if you don't make a new deployment. So even if you don't deploy, there's still things can go wrong, right? Like cache issue is one, and network connection issue is one. So you'll also be able to find out those issues even when you're before your customer. So let's say if in the middle of the night, there's no really a lot of customer activities. If something wrong, without the canary, your alarms will not go off. But with the canary that is keep calling you, you will notice those issues early. So the difference to the continuous deployment is that in the continuous deployment, we only do this test once. That's when we run when we do the deployment. Right? So we deploy to beta, and we run the test once. If it succeeds, we push it to gamma. We run the test once. If it succeeds, we push it prod. And in prod, I believe usually people do it in the test. But here it's different. It's kind of more continuous way. We keep testing our system.
So we are like participating like ourselves as our customers.
As our customer, yes. Yes. Okay, so these are actually the technical parts, but this is one last thing that I want, or one last tips I want to share with you. But I also think this is probably the most important one. So, if you really want to only remember one thing from today's talk, remember this one. So bicycle action. So this is a principle. So this is a principle. So actually, this is like one of the Amazon principles, but I found it's like very true for startups as well. So what is that? So what do you think is the most important factor to a successful startup? Is it having the greatest idea? Ideas, like great ideas, are very important. But do you really need to wait until you have the greatest idea and then start working on this? I would argue not. Action are more important. So you have like the idea, like even it's just an okay idea, you can act on it, and then you can refine your idea when you interact with your clients. And in this process, you understand the market better, and you can adjust your idea, and you can even change it. You can change your initial idea, and then you develop like you'll be able to develop better ideas when you work on this, and you may see new opportunities that you won't get to see before. And this time, when you see those opportunities, you are at a position that you are ready to seize them. Okay. So roll up your sleeves and just do it. Thank you very much.
Are there any questions?
How about costs? Like, is there a balance between some kind of scale and the cost?
The cost of I think the techniques I went over today, they really optimize. They optimize for cost as well. So it scales well, and also if you use like like Lambda functions and also variable scalable, say TechStack, you only add host to it when you need it, and when it's idle, you can just remove a lot of this hosts. They don't sit there idle, so they are actually they're cheaper, and they're using cheaper hardware. So.
But in recent years, I mean, it seems the space has become very competitive, and then the infrastructure is very good in terms of like performance. So you're seeing a lot of startups that have the basic infrastructure, but they still don't have, like I think you did briefly mention about infrastructure as a code. I think that's probably the biggest area of development. And then like for a startup, it seems to be a big challenge in terms of like having that minimum infrastructure that is cost effective, and you can't providing software on top of that. So I think that seems to be the bridge that many startups.
It's true, but also I would say it's a one-time investment as a startup.